Hi, myself Dr. Kavita. In this session, you will be studying about hormones. I hope you all remembered about hormones that you have studied in your PU classes. Here, you are going to study little bit more chemistry of hormones. You know hormones. Hormones are the organic compounds or chemical compounds secreted by the ductless glands of the body. Example for ductless glands, thyroid gland, adrenal gland and pancreas gland, etc. And these compounds are carried by the bloodstream to another part of the body for its function. That means they are secreted in one part of the body, but they perform their function in another part of the body. Then the question is, who will carry them? The answer is blood. They enter into the bloodstream and find their way to various organs of the body, and then they exert their function. And they carry the information from one set of cells to another set of cells. Hence they are called chemical messengers. And these hormones are secreted in very minute quantities at a time, and they are highly specific in their physiological function. So next, classification. Chemically, hormones do not resemble each other, and they are classified into two different types based on physiological activity. First one, sex hormones. Second, adrenocortical hormones. So we'll study a little bit about sex hormones. What are sex hormones? So these are steroid class of compounds produced in gonads. Their activity is controlled by the hormones that are produced by anterior lobe of pituitary gland, and these hormones are responsible for sexual processes and for the secondary characteristics which differentiate male from female. Then there are two types of sex hormones: female sex hormones and male sex hormones. Female sex hormones, there are two types: progesterone, estrogens. Progesterone is required for normal pregnancy. Estrogens, they control the ovulation cycle. Then male sex hormones, the primary male hormone testosterone is secreted by testes and is responsible for the secondary male sexual characters. The other hormone is androsterone, and it is responsible to maintain the activity of prostate gland, seminal vesicle and genitals. It is also responsible for the development of secondary male sex characters. Second type, adrenocortical hormones. Adrenal cortex, the part of adrenal glands present on the top of the kidney, secretes 28 different hormones. Okay, out of these, the two important steroid hormones are cortisone and cortisol. Adrenocortical hormones are very important in regulating physiological processes of the body, which include carbohydrate metabolism, protein metabolism and lipid metabolism, and also they are important for water and electrolyte balance and reactions to allergic and inflammatory phenomena. Okay, then we will be studying the synthesis of adrenaline. So adrenal glands, which are located above each kidney, has two parts: the medulla, central part, and the cortex, the outer part. The medulla secretes two hormones. One is adrenaline, other one is noradrenaline. And these hormones are necessary for the transmission of nerve impulses in sympathetic nervous system. It raises the level of glucose by splitting deposited glycogen of liver into glucose and increases metabolic rate. It also increases blood pressure by the contraction of small arteries. Okay, we will be discussing the synthetic part. So first one, from catechol. So this is the structure of catechol. You know about phenol, right? Benzene ring with one OH. If you write another OH adjacent to that or ortho to that, then that is catechol. catechol on treatment with chloroacetic acid in presence of phosphorus oxychloride, then it forms a compound. Para position, there will be a substitution of COCH to Cl. Then we need to treat with methylamine. Then there will be a liberation of HCl. Then we'll get COCH2 NHCH3. Then we subject it to reduction. So when you subject this molecule to reduction, then CO group, that carbonyl group, get reduced to CHOH. And this is the structure of adrenaline. This is a mixture like plus and minus, dextrorotatory and levorotatory. Okay. Then there is another method from protocatachoic aldehyde. The structure is just catechol, you know, right? Para to that, if you write CHO, that is protocatachoic aldehyde. Okay, there will be a 2 OH group adjacent to each other, and para position there will be a CHO group, aldehyde group. If you treat with HCN, it forms addition product, that is Ca to the aldehyde, CHCnOH. Then if you carry out reduction using nickel and hydrogen, then you will get Cn will get converted into CH2NH2. Then we need to carry out methylation using methyl iodide. Then we'll get the structure of adrenaline. Okay. This is the synthetic part. There are two methods. One from catechol, another from protocatachoic aldehyde. Both are simple only. So you can refer these textbooks. Thank you.